An ice core is a beautiful and enigmatic artefact. Embedded in ice are tiny bubbles of air from hundreds of thousands of years ago. When you drill into an ice cap that is kilometres thick, you can extract a core that is layered year by year, a precious archive of deep time. I think that ice cores are the holy scripts, the sacred scrolls of our age. I want to take you on a journey into the ice. What secrets of the past and the future does it hold? How might our destiny be bound up with its fate? Although the messages from the ice are grim, I don't want to be too apocalyptic. I also want to be celebratory. I think some of the most exciting research one could possibly do at this moment in the history of the world is the science and history of the ice, and especially in Antarctica. I feel lucky to have visited both of Earth's polar ice caps. 4 years ago, I was in a tiny fishing boat in Greenland and we sailed perilously close to fragmenting icebergs in an ice-choked fjord. I learned later that 5 people die every year in that bay from doing this, mostly Inuit fishermen from a small community of 5,000 people and 8,000 sledge dogs. We were in Ilulissat, under the eaves of the bergs in Disco Bay, at the mouth of the fastest moving glacier in the world. It's now moving 40 metres a day, and its pace has doubled in the last decade. The Surmet-Kuilek Glacier is allegedly the source of the iceberg that sank the Titanic. Now it is a physical and political frontier of climate change. This is where US senators fly in to get a visceral sense of what greenhouse gases are doing. 9 years ago, and again this year, I voyaged to Antarctica and experienced that awesome encounter by sea with the ring of ice that surrounds the southernmost continent. You sail directly south from Australia, across the stormiest sea in the world, for 9 days, and finally, the ocean stills. For you are amongst giants, the icebergs. These great bergs made me shiver with more than cold. In their stateliness and marbled grandeur, they stir a frisson of fear because of what they come from, because of what they are fragments of. You are heading towards a giant ice-making machine, and these are the most trivial of its industrial rubble. In January, I was on board the Australian Antarctic Division ship Aurora Australis as part of the team commemorating the centenary of the first Australasian expedition to Antarctica led by Douglas Mawson. Would the ice allow us to get close enough to the continent? Would the blizzards relent and the fog lift so that we could fly in by helicopter to Commonwealth Bay, where Mawson established his hut in 1912? We had to wait our chance, anchored on the edge of the sea ice, and fortunately we had the Adelie penguins to entertain us. In Antarctica, you can feel like time has not only skipped a beat, but has lost the beat altogether. Time there assumes different rhythms. There's the deeper pulse of the ice ages, the seamless months of eternal light or night, the transcendent otherworld of the blizzard, the breaking up of the sea ice, the exciting return of the Adelie penguins in spring, the schedule of the summer ships, and the intensity of the annual changeover of staff at Antarctic stations. A century might signify 100 generations in Antarctica, or just one tick of the glacial clock. In such a temporal whiteout, what does 100 years mean, or 1,000, or 1,000,000? The challenge of environmental history is to relate these different timescales meaningfully, to link deep evolutionary time with our experience of daily social time, to work audaciously across time and space and species. Well, the mist did lift, and we made our pilgrimage to Mawson's famous huts. From this humble hut, Mawson and his men launched the most impressive scientific expedition of the heroic era of Antarctic history. Mawson didn't want to race to the South Pole. He wanted to explore his own backyard, the stormy sea and icy air, the ice shelves, the unknown coastline south of Australia, that he felt was his own country's destiny to understand. And Mawson The geologist was desperate to see an ice age in action. He was not just exploring the ends of the Earth, but also sensed that Antarctica somehow held the key to the deep history of his planet. Just 100 years ago, we didn't know much about ice. At the beginning of the 20th century, explorers still thought they might find polar bears in Antarctica. They fought the ice to reach abstract goals like the South Pole. Men hauled sledges doggedly across the surface. It wasn't until the mid-20th century that we discovered just how much ice was beneath their feet. Men in tractors traversed the continent doing seismic soundings and measuring the depth of the ice sheet. They thought it was no more than a few hundred metres thick, and so they were stunned to find it was kilometres deep. They doubted their own arithmetic and rechecked their measurements in disbelief. It turned out that the driest of all continents was actually a vast elevated plateau of frozen water. This startling discovery, little more than half a century ago, revealed that the world's sea level is principally controlled by the state of the Antarctic ice sheet. So 100 years ago, the defining Antarctic journey was the sledging expedition across the surface of the ice. 50 years ago, it was the tractor traverse that measured the volume of the ice sheet. Today, the defining Antarctic journey goes straight down, with the help of a drill, from the top of the ice dome to the continental bedrock, a vertical journey back through time. And the ice core extracted enables us to see our civilization in the context of hundreds of thousands of years of climate history. Right now, in Antarctica, the international race is on again, not for the South Pole, not for the first transantarctic traverse, but for the first million-year ice core. One of the responses I had to seeing both ice caps was to be reminded of just how much ice there is on Earth. Although we live in what's called an interglacial, we are still living within an extended epoch of cyclical ice ages known as the Quaternary that began over 3 million years ago. We are currently between ice ages, each of which lasts about 100,000 years. Now, in the mid-19th century, a fine scientist shocked his colleagues and the public with a revolutionary view of the global past. I'm not talking about Charles Darwin, although that intellectual revolution was going on in parallel. I mean the charismatic Swiss-born professor Louis Agassiz, who in the 1830s proposed not only that glaciers had moved rocks around and later retreated, but that whole countries had once been buried under miles of ice. It was a startling new view of Earth history. Antarctica is Louis Agassiz's dream, or nightmare, discovered on our planet in our own time. That's what Mawson wanted to see. Antarctica is where 90% of the world's land ice sits. It's where 70% of our fresh water is locked up. Our concerns today about the history of the air, about greenhouse gases, had their foundation then in the 19th century in a curiosity about the history of ice. So it's these early investigations into the causes of ice ages that underpin modern climate science. And the scientists who did this groundwork were mostly lone, underfunded and part-time researchers pursuing a rather abstract quest. They weren't speculating about the future, they were investigating the ancient past. And where they did speculate on future global warming, they saw it as generally positive. The prospect of several degrees rise in temperature was greeted equably, especially by scientists in Sweden and North America and Britain. Indeed, if the world were warmer, it might make winters more comfortable and agriculture more productive. It might even help stave off the next ice age. For the first two-thirds of the 20th century, the global warming trend was called the embetterment of climate, or the recent amelioration. But then, in the 1980s, something happened that scared the hell out of us, and it was ice that delivered the message. Until the early 1980s, there had been a reassuring assumption that if global warming was happening, it would happen slowly, at a stately pace, as it had presumably happened in the past. But ice cores from Greenland revealed that climate change had often occurred abruptly, with temperature changes in the North Atlantic of 6 degrees Celsius or more in a few decades. Then, in Antarctica in the 1990s, a long 400,000-year ice core was extracted from the middle of the ice sheet near the Russian station Vostok. And the Vostok core, with its beautiful, rhythmic, sawtooth graph charting 4 full cycles of glacial and interglacial periods, established that carbon dioxide and methane concentration in the atmosphere had moved in lockstep with the ice sheets and the temperature. It also revealed that present-day levels of these greenhouse gases are unprecedented during the past 420,000 years. Before Antarctica was even seen by humans, it began recording our impact. Here is the variation in carbon dioxide over the last 1,000 years, as recorded in an ice core taken from the Law Dome near Australia's Casey Station. You can see the leap in the CO2 levels since the Industrial Revolution, and you can also see smaller natural variations in the earlier period, some warmer centuries after 1000 AD, and some cooler ones, especially around 1600. Well, let's look more closely at those natural variations in the past 1,000 years of human history. How are we going to pick up variations of less than 1 degree Celsius before we had reliable thermometers? Well, historians turn to the documentary records of wine and ice, to the fluctuating dates of the grape harvest, and to written accounts of the advance and recession of glaciers in alpine valleys. And they provide a surprisingly fine-grained record of temperature variation. And what we learn is that there were 2 significant sustained temperature fluctuations in the past millennium. One is known as the medieval warm period and lasted from about 900 to 1300. And the other is called the Little Ice Age and began about 1300 and ended about 1860. Each of those fluctuations was tiny compared with the great swings of temperature associated with the ice ages, or those that we now face. They were in the range of only about 1 degree Celsius. But even those relatively small fluctuations had dramatic effects on human geography and society. Most famously, Vikings colonised Iceland, Greenland and North America in the medieval warm period. Their long ships could go further as sea ice contracted and storms subsided in intensity. And grass and crops could be grown where there'd just been ice or permafrost before. Then, as the medieval warm period cooled, those northern Viking settlements were abandoned and the ice re-invaded pastures and seaways. In Europe, the Little Ice Age ushered in more extreme weather events, serious famine, contraction of agriculture, the abandonment of villages, and the spread of the Black Death. The coldest years, around 1560 to 1660, were the period of the witch persecutions. Political and economic structures were challenged to their core. Climate wasn't the only governing factor in social change, but it profoundly affected where people could live and how they could make their living. And these average temperature fluctuations were all within 1 degree Celsius. What a difference a degree makes! And we are facing at least 2 degrees, maybe 3, maybe 4. When we hear that global warming might bring average global temperature rises of 3 or 4 degrees, we can so easily think, well, that's less than the variation I might experience in a single afternoon. It's sobering then to realise that average global temperature variations of less than 1 degree have transformed and imperilled human society. When we look into an ice core going back almost 1 million years, we're looking into the layered years that saw the evolution of humanity. We are a species of the ice ages. Here, indeed, is our creation story. They really are our sacred scrolls. About 3.6 million years ago, the first Northern Hemisphere glaciation of the current epoch of cyclical ice ages reduced rainfall in East Africa and forced the least specialised and most versatile apes to the edges of the contracting forests. There they faced severe pressure to innovate or perish. Interglacials enabled the stronger survivors to consolidate, while the next ice age tested and extended their descendants even further. The drier cycles brought by the ice ages, 10 or a dozen every million years, pushed early humans out onto the plains, encouraged them to walk upright, and demanded that they live on their wits. By the time of the last ice age, fully modern humans had spread across the globe. And the most adventurous of those humans reached Australia. When Europeans and North Americans look for cultural beginnings, they're often prompted to tell you that humans and their civilizations are products of the Holocene, which is the last 10,000 years since the end of the last ice age. By contrast, an Australian history of the world takes us back to humanity's first deep-sea voyages of 60,000 years ago, to the experience of people living with cold ice age droughts in Central Australian deserts, and to the sustaining of human civilization in the face of massive climate change. It is an inspiring parable for the world, to be found on our own continent. In the last 200 years, though, a new factor is forcing climate change: runaway increases in carbon dioxide. We're changing the climate by digging up the dead, by bringing to the Earth's surface the fossilised organic matter of once living things and burning it. As a result of our own actions, we are now moving beyond the natural temperature fluctuations of the last millennium. And we may also be leaving behind the Holocene, the last 10,000 years of relatively stable climate. Even more disturbing is the knowledge that we may have destabilised the Quaternary, the several million year period of cyclical ice ages that has seen the evolution of modern humans. These, then, are the secrets of the ice cores. It is a human triumph that we have retrieved them, and that we can read them, and surely now we will act on them. Ice created us. Perhaps it can also deliver us. Thank you.